let's start dipping into your research a little bit. And just off the top, I've heard anything from hop creep is microbiological. I've heard that it's something enzymatically going on within the hops that are being added to that. What has what have you learned about it? What has your research shown about what's actually happening with hop creep? I guess what it is, and then maybe what's helping to drive it.
Sure. This is such a big question.
I know it's massive, so
Yeah,
we'll
yeah,
we'll try to
yeah,
peel through it.
yeah. Um, I think, yeah, I feel like I've kind of, after a few years of doing my research and really digging in, I decided I really needed to make a solid definition for people. And so I'll just say the definition now.
Yeah, yeah.
Hop creep is the unintended secondary fermentation that comes from adding hops on the cold side. So
Mm,
you dry hop and you get a secondary fermentation, period.
mm,
That is hop creep. And I have a bit of a broader definition than maybe some of the other uh, researchers doing work on hop creep because I've looked into the other side of it. Um, and so, yes, Charlie published a paper. I should back up. So the Shellhammer Lab has done so much great work on starting exploring hop creep in a real way. And all of their research does focus on the enzymatic process. And these are the enzymes that we're familiar with as brewers: alpha amylase, beta amylase, which we love in the mash, give us our beautiful sugars for the yeast. But they're also being added with the hops. So we can confirm that they exist on hops and they're getting added into the tank when we dry hop.
mm.
It has not been confirmed that they actually are doing enzymatic processes, but we have confirmed that they exist. The
Is that in part because of the temperature range at which they're being added, or am I just
mm,
completely off base?
you're not off base for thinking that. Temperature is obviously extremely important
Mhm.
for when we think about like starch conversion in the mash. But we have to remember that these enzymes operate in a huge range. And two, the plant is using these enzymes at room temperature, right? They're using them. My dog is snoring. I'm so sorry. I don't know if you can
Oh,
hear
you
it.
can't. I can't hear anything. You're all
Okay.
set. No, 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 you're good.
Um, these enzymes, the plants are operating at room temperature, so to speak, throughout the
Mhm.
day. And the enzymes that they would be using for their own starch breakdown are at room temperature. And so they will still be active. It's just going to be the rate of the reaction would be
Mhm.
happening, right? The only thing that would end their usage at that time would be denaturation, which can happen through pH or temperature, things like that, which we're also still familiar with from the mash. They are likely still working. We've made those dextrins in the mash that we expected to last and make the recipe balance really nice in our beer. It's speculated that they are working on the dextrins. Those dextrins get broken down, and then you have re-fermentation of those simple sugars. That is the theory that's been around for years and years and years at this point. Then you move on, and Charlie Bamforth came up with this. He was the first person, I think, to really start opening that box up and say, like, hey, can we look at this from a new perspective and think about it a little bit differently? I really appreciate that from Charlie because it makes me ask different questions too when I was really bought into the enzyme story as well, which is really important. I'm not discounting it, but Charlie then said, what if it's not the hop cone itself? What if it's the microbes contributing those enzymes? You know, there's microflora on everything in every single way. And so I dug pretty deeply in that, and that's the paper that was in Food Micro, and kind of said, okay, it could be possible, probably possible that they're adding those enzymes. But I was also doing work. I was doing some work for Russian River at the time, kind of like doing some sciencey consulting. And at the time, I was reading a bunch of papers on biotransformation, and I kept reading the word glycosidically bound, and thought that's sugar. We're saying we're releasing a sugar. And that made me start thinking, well, what sugars are we adding with hops? I don't know. No idea, but I know that there's at least some getting released from those glycosidically bound precursors that are bound to things like linalool that we know are there in hops. And so I started digging into the sugar aspect of hops and found lots of things within that that we can dig into, but there is a significant amount of sugar that comes from the difference of simple sugar within the hop that's just there, and then additional sugar that is being released from those plant secondary metabolites. And then the most recent discovery I made, which using just the old iodine brewing trick, is starch is also in hops. And this is like super fun and cool, I think. Very exciting, but it's a leaf. The bract is leaves, apparently, and we don't think of starch to be in that format in plants, but plants do cool things like diurnal starch accumulation. And so throughout the day, they're so efficient at photosynthesis, making their energy, that they have too much glucose. And they say, I'm just going to save this up for overnight. And then they hold on to it and they build it and build it and build it. And then they break it down overnight. And so you have this like beautiful little curve over the time of the day. And so I just learned about this. I was auditing a plant class because I don't know anything about plants apparently. And I was like, no way. I left the plant class, ran back to the lab, took some whole cone hops, and then stained them with iodine and saw that under the microscope, which are the photos in that paper. And I was just so taken aback, like, what the heck did we just find? Super cool. But anyways, back to the hop creep story. If we're talking about the plant secondary metabolites, those single sugars, that's one sugar that's being added in at X amount, but starch is thousands and thousands of glucose single units that would then be broken down and added to the beer. And if you actually are able to track your fermentation closely enough, every time you dry hop, you actually see it increase before it decreases. And sometimes you can catch it, sometimes you don't, depending on the time of day, your fermentation, your dry hop when you're taking the sample. But very often you see that 0.1, 0.2 bump up, and you're like, well, what is that? Oh, it must be the sugar from the hops. I'm kind of questioning it because the enzymes are also stored on the starch itself. And then you're putting it into solution. I mean, that's a little bit of speculation there. That's just me hypothesizing about how this starch is getting broken down. But if you're a molecule in a tank, are you going to work on the thing next to you, or are you going to fly really far away and find the dextrin and then work on that? Eventually, yeah, but when you see that increase, what is it?
So. Yeah.